Welcome back, dear student. Many a times in physics, if you analyze the geometry of the motion, then it saves a lot of your mathematical work and a lot of your time. So here is one such example in which you see there are three blocks and all blocks are moving in this. They are having relative motions while always being in contact as shown. The question says, a wedge A of mass m and base angle 45 degree is placed on a horizontal floor with another wedge B of same mass and same base angle set on top of it. That means this is a wedge and it is an isosceles triangle with this angle being 45 degree and its mass is capital M, and this wedge, it is also having mass capital M, this angle again 45 degree, so that this surface is horizontal and this block, small block, is having mass small m. The question says, if the system is released from rest, then you have to find the acceleration of this block, C block, and all the surfaces have been assumed to be frictionless. Acceleration due to gravity is g. So let us analyze the geometry of the motion. You see, this is our situation, and if we take this is as our system, what do we feel? Is there, and the friction on this surface is 0. So as friction is 0, there will not be any horizontal force acting on this whole system. Only vertical force will be acting. Some normal reaction by the ground, that is the only vertical force acting on the system. Horizontal force is 0 on the system. That means we can very clearly say that the center of mass of this system will not move in horizontal direction. It is a very big hint in this question, because you see here also the situation is same. It is horizontal and mu is 0. So C will have vertical motion only. It can't have a horizontal motion. That means which two bodies can have horizontal motion? Only A and B. Only they will have a horizontal component. Now A can move horizontally only because it will always be on the ground. Let us say A moves in backward direction with some acceleration A. Okay. Now as we have seen that the center of mass should not move horizontally, that means the horizontal component of acceleration of B should also be A in order to cancel the effect. Okay. So this is what we can say from the symmetry. Now let us see how the geometry is going to help you. This is the situation. We have seen that if this moves, let us say, in a very small time interval dt, this block A moves backward by distance, let's say dx. That means the horizontal component of the displacement of this block, it will also have to be dx, because center of mass has to remain at rest and C has no horizontal motion. Okay. Now if both of them are, let us see how the situation will become. It will become something like this. Suppose we are holding the block B in air, we are not allowing to move it down. Simply we have moved this by one hand and we have moved this by other hand and we are holding it. So situation is something like this. What do you think this distance should be? Here you see dx A went backward, dx B went forward. That means this distance will be nothing but 2 dx, isn't it? So now since we are holding it, we are holding the block B with our own hand, and also we know that it has to remain in contact. A and B have to remain in contact. That means we have to bring B downward now. How much downward we have to bring? You see this triangle. This is also isosceles triangle. So, and 45 degree is the angle. So this distance will be what? 2dx only. So you see what is happening to B. B is moving dx in this direction and 2dx in downward direction. So by differentiating, by dividing with time, double derivative, you can very easily relate the two accelerations of B. And what can you say about the motion of B? Motion of B will be something like if it is having horizontal acceleration a, it will be having vertical acceleration what? 2a. Okay, this is for block B. One important thing we got. Now, what is the horizontal acceleration of A? As we have seen in the previous slide, that if B is having horizontal acceleration of A, then A is also having backward acceleration of A. So, here what is the story of A? A also will be moving in backward direction with same acceleration A. Okay, this we got for the A. Now, what can you say about the C? Here you see, C is just sitting on the top of B. That means they have to be in contact with each other. So, if B is moving down with acceleration 2a, then C is also bound to move downward with acceleration 2a only. So, what can you say about the acceleration of C? It is having the same value as that of B. So, it is moving down with same acceleration. See how beautifully just by geometry we have got all the acceleration in terms of only one value A. Okay, and what we have to find in our answer? We have to find 2a, because the question is asking what is the acceleration of C. So, as we have got it, now let us simply write the fourth equation and very easily we will get the answer. Let us see how. Let us say the normal interaction force at this surface is N. N means C is feeling a normal force N upward and B is feeling normal force N downward. Similarly, let the normal force here, normal interaction force be N1. N1 on this and N1 on this. Now, you draw the free body diagram and very easily you will get the answer. Let us write the equations here. How? For the C I am talking. This is C. So, for the C what is happening? It is feeling a force mg, its mass is small m. So, mg downward is the force and upward what force? N. N. And in the previous slide we have already seen its acceleration is what? 2a downwards. That means what we can say? Mg minus n is equal to mg minus n equals to m times 2a, first equation. Okay. What can you say about A? A, what we have seen? This is A. What are the forces acting on this? It is feeling a force what? N1. N1 force is acting in this direction and its acceleration in backward direction is what? A. So, clearly we can write N1 by root 2 is what? Capital M A. This is the second equation. Now, let us come to the block B. This is block B. What we have already seen, that its horizontal acceleration is here is A and vertical acceleration is 2a. We have already seen in the previous derivation. Now, see what are the forces acting on it. Forces are N1 in this direction normal, N due to the block on the top and mg downward due to its own weight. Okay. Now, you equate the vertical forces. Vertical forces are what? Mg plus top force N minus N1, N1 this component, N1 by root 2, N1 by root 2 is equal to what? Downward we are calculating, so it should be m times 2a. M times 2a is the acceleration. So, this is the third equation. Now, very easily you can say, if you put 1 and 2 in 3, 1 we have got n1 by root 2 and n from here. So what you get mg plus n is what? mg minus 2ma plus mg minus 2ma minus 2ma minus n1 by root 2 is what? ma. If you bring it to right, it becomes plus ma. So it is what? It is 3ma. So what we can say is that a is what? M plus small m times g upon thrice of capital M plus twice of m. This we got as A. What is our aim of the question? Aim is to find 2A, because 2A is the downward acceleration of block C. So our answer is 2A. 2A is what? Twice of m plus mg upon 3m plus 2m. This is our final answer. So if you see here, geometry has played a very important role, and otherwise if you could have solved by a purely general mathematical approach, it would have been a very long question. So I hope you liked the video, and if you have any suggestions, any advices, any doubts, any questions, queries, please feel free to ask in the comments. Thank you.